Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 142 called the linked list cycle 2. And for this particular challenge, we are using a TypeScript as our language, or JavaScript if you prefer, but if you want to use something else other than JavaScript or TypeScript, then go ahead, I encourage you to do so. And for this particular challenge, we have the function of the detect cycle that takes only one parameter called the head in the form of listNode custom class, which defined from this commented code right here. Definition for the singly linked list of the listNode called class listNode, which has the value of fall or the value and the property of next, which points to the another listNode class. It's either listNode or a null, so it is a one-way trip from the one listNode to another listNode, and this is the constructor if we happen to create another listNode just in case. But for this sake of the challenge, we are not going to create another listNode. Then the head it is possible to be a listNode class or null, and also the output is either a listNode or null. And we have the description that says, given the head of a linked list, return the node where the cycle begins. If there is no cycle, and we have to return null, so we can simply pass in the return statement of the null right away, just in case if we happen to not finding the answer at all. And on top of it, there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tells next pointer is connected to 0 index. It is -1 if there is no cycle, not that the position is not passed as a parameter. We don't have to worry about the index thing or the -1 or something, and the post is not passed a parameter, and we are not going to modify the linked list, so bear with me. And we have the example one right here, which is a linked list considered a cycle linked list, which is only one way, but it is a cycle 3 to 0 -4 and then go back to the 2 0 -4, and then it will go on loop infinitely. And we have the input of the head, which has the composition of the whole linked list of the 3 to 0 and -4, and we have the answer of position 1, and the output it says tail connects to node index 1, which is starting index 1, which is 2 right here, starting as the starting cycle of the whole linked list cycle. So after the -4, it goes back to the node 4 node 2 again, which is on the index 1, so this one is going to be returned as the position of the said index. And the explanation, there is a cycle in the linked list where tail connects to the second node. And for the example number 2 right here, we have head, which consists of 1 and 2, which is, and the position is considered as 0 is because the index which connects the last node to starting a cycle again, it begins on index 0, but it is contradicts with our implementation right here, because the TypeScript right here of the function of the detect cycle, either a TypeScript or JavaScript, it is expecting a listNode, either listNode or null. So instead of returning the index, we have to return either listNode or null, but null is denoted by the -1 right here to represent that it is not in a cycle at all. So after the node 1 will point to the null to null, so there is no node at all, so and there is no anything to connect back the node to the node 1, so hence the position is -1 denoted by the index, and we have to return null instead. So the null is the same as -1, and then the index 0, we can, instead of using the index as the answer, then we can return the current listNode in a form of listNode, which is 2 right here, node 2, and then 0, and then -4, using the pointer just like we did yesterday of the previous challenge of the linked list cycle on the challenge number 141. So for the sample 3 right here, we have the head which not connected to anything, and we have no cycle, and there is no cycle in the linked list, so we have to return null right away. So let's solve this out. But First, let me tell you the thought process of this challenge. For the previous challenge, we are detecting if it is a cycle or not, whether it's a cycle or not, by using the turtle and the rabbit technique or Floyd cycle detection, or in other words, it's tortoise and a hare, which has the same name. The one pointer that moves slowly one at a time, and the other one moves 2 times in a row or 2 nodes at a time. And the fast and slow pointer will meet halfway or in the same node, and then we return this as a true using the if check. But for this one, we will slightly modify the code to see which which node that has the cycle starting all over again to determine the loop. So let me copy this image, and we can just move to Excalibur drawing, and we can paste this into the Excalibur. This is too big, and let me resize this, and we are using the technique called the tortoise and hare. And let me draw an arrow. This one is the T, or the tortoise, or the turtle, you name it. And another one, see another arrow with the color of blue. We can name this the hare or the H. Let's say we are starting from the index 0 or the node 3 right here. As we move, then the hare will move 2 at a time, and the tortoise will move 1 at a time, and then the hare will move 2 at a time again for the next iteration, and the tortoise will move 1 at a time. So they are both in this state of the second iteration of the while loop, and then the tortoise move 1 at a time, and then the hare will they are going to both meet halfway in the same node. And we on the previous challenge, we are returning this as the answer. We are returning this as the answer if it is in a cycle or not, because the hare is meets with the tortoise, so the cycle returns true and we return the answer. But for this one, we need to slightly change this. If they are already meeting each other on the same node, they are placed on the same node by this current state, then we need to reset one pointer, either the hare or tortoise moves. We are going to move it back to the starting point, and the other one will stays at the current node that they have been meeting halfway. And for the next iteration, we have to modify the hare to move 1 at a time, either the hare or tortoise, so they are both move 1 at a time. Instead, the other one will move 2 at a time, and the other one will move 1 at a time. So we have to modify this after the if check already passed. Then we can move the tortoise 1 at a time, and we move the hare 1 at a time. Then after they are meeting again, then this is the node that we are talking about, which is the node 2, and then we return node 2 as the current head of either the pointer of the tortoise or the pointer of the hare. They are both the same thing since they are both points to the same node, and we can just return either of them. Then we will return this as the list node as the answer. The same thing goes to the example 2 right here. I need to copy this image and go back to the implementation of the Excalibur drawing. Let's say we have the tortoise that places on the starting point, just like on the hare. Let me send this to back. And the tortoise, they are both starting at the same point. And for the first while loop check, the while loop will operate them. The hare will move 2 times and the tortoise will move 1 time. Since hare moving 2 times, 1, 2, then the hare will goes in circle to the 1, and the tortoise will move to the node 2 because it is moving 1 at a time. Then for the next iteration, the hare will move 2 at a time, 1, 2, and it still stays at the node 1, and it seems that hare is not moving at all because it is only moving 2 at a time. Then the tortoise will move 1 at a time, and they are both meeting on the same point or the same node. Then we use another check. If it is already been completed, they are both meeting at the same point, they are both rendezvous at the same node, then the one of them will resets back to the starting point of the current head node, which is the parameter itself. Then we can utilize that, and since the tortoise and the hare, either the tortoise or hare, will go back to the set point, starting point, since the starting point is node 1, then they are both meeting on the same node again. It is automatically stated as another if check. Since they are both the same on the same node already, then we can just return the answer of either pointer as the head. So let's go back to our implementation by using declaring the let pointer of the tortoise. We can declare this as the head, reference the head, and another let called the hare that moves 2 at a time, and then we point to the head, and they are both starting at the same head. And then using the while loop, as long as the hare is not equals to null and the hare dot next is also not equals to null, and checking forward if it is not null. As long as it's not null, then we can move the tortoise and hare freely. Using the tortoise will move 1 at a time, using tortoise accessing the next property, assigning to the current tortoise pointer, and the hare will move 2 1 at a time in the next, and then another next again. And we can use an if check from the previous challenge. If they are both on the same head reference, if the tortoise same as hare list node, then we can use the hare as the hare, not the hare but the tortoise. Oops, we can use hare or tortoise, whatever. We can use hare, and then we place the hare back to the head, and we can use a while loop. While as long as tortoise, the head reference, is not the same as the hare, then of course we move the tortoise by 1, starting all over again from this while loop code. We use the nested while loop, we don't have to worry about that, and tortoise will move 1 at a time, tortoise dot next, and the hare will move 1 at a time. No matter which pointer that we need to go back to the head goes back to the head, then they are still meeting at the same starting cycle. And if the while loop already finishes, or another meaning that they are both at the same head reference again, then we will return the hare as it is. To take note that after the if check already been triggered right here, then we will go to the nested code using the while loop. We are letting the hare goes back to the head node again, starting all over again, and then while loop using the while loop check. This while loop, as long as the tortoise and hare reference of the current node is not the same, then of course we will move the tortoise by 1 and the hare by 1. So that is the difference between using the first while loop and the second while loop process. The hare dot next is moving 1 at a time, and the tortoise dot next is moving 1 at a time. Then we can just run the code to see if it works, and we have accepted solution. So let's submit the code to see if it really works, and we have the runtime of 44 milliseconds. So that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.